Welcome to the AI for Technical Writers podcast. This is episode 91. I'm Fred.
And I'm Daphne. It's great to be here.
Today we're tackling a really critical challenge for anyone working with AI, especially, in technical communication or IT roles.
Absolutely. We're talking about AI hallucinations, those times when a language model just seems to, well, make things up.
Yeah, it's a frustrating issue. This topic was actually suggested by our producer, senior technical writer, Kurt Robbins. He pointed us towards a really interesting article.
He did. The main source we're looking at today is titled Why Language Models Hallucinate. It's by Adam Tauman Kalai, Ufur Nachum, Santosh Esvampala, and Edwin Zhang, and it came out September 4th, 2025.
And understanding this is so important, isn't it? For technical writers, documentation specialists, IT pros, anyone building or using AI tools where trust is paramount.
Exactly. Knowing why this happens is the first step towards building more reliable systems.
Okay, so let's unpack this. What exactly is an AI hallucination? It's not like a human seeing things, obviously.
Right. The paper defines it pretty clearly. It's when a large language model, faced with uncertainty, essentially guesses.
Instead of just saying, I don't know.
Precisely. It produces these plausible-sounding statements that are actually incorrect. Think of like a student bluffing on an exam, writing something down confidently, even if they're unsure.
And the worrying part is these aren't just tiny errors, are they?
Not at all. The authors stress that these hallucinations persist even in the most advanced state-of-the-art models, and that really undermines trust.
Yeah.
They give some vivid examples, too.
Right, like asking a top open source model for Adam Tauman Kalai's birthday. They even told it, only answer if you know for sure.
And what happened?
It gave 3 different dates. All wrong. His birthday's in autumn, apparently, so they weren't even close guesses.
Wow.
Or trying to find out his PhD dissertation title. Different big models, ChatGPT, DeepSeek, Llama, they all just invented completely fake titles in years.
Just made them up wholesale. That really illustrates the problem, and the paper makes a useful distinction here.
Between the different kinds of hallucinations.
Yeah. They talk about intrinsic hallucinations. That's when the model contradicts something right there in the user's prompt.
Okay. Like the example they gave with counting Ds in the word DeepSeek.
Exactly. The prompt gives the word, but the model might confidently say there are 2 or maybe 3 Ds when you can clearly see there's only one. It's contradicting the input.
Got it. So for someone listening, maybe a tech writer, that might be like asking an AI about an API parameter you just provided, say authentication key, and it insists on calling it auth token.
Precisely. It conflicts directly with the immediate information. Then there are the extrinsic hallucinations.
And those are the ones that contradict,
Yeah.
the real world.
Yeah, or the model's training data, or just external reality, like those made-up dissertation titles.
Okay.
For you, that could be an AI confidently describing a software feature that simply doesn't exist. Or maybe for an IT person, asking about a security patch and getting completely fabricated details about it.
Right. Details that clash with official advisories or reality. Okay. That distinction makes sense.
So where do these errors actually come from? It's not just random noise, is it?
No, and that's what's so interesting about this paper. They argue it's not some deep mystery. They trace it back to the very first step, pre-training.
The stage where the model just learns patterns from massive amounts of text.
Exactly. Learning the sort of statistical distribution of language is like the AI's foundational schooling.
And the really counterintuitive point they make is, even if that training data was perfect, completely error-free.
Which it never is, let's be honest.
Right. But even in that ideal scenario, the way these models are trained, the mathematical goals they're optimizing for during pre-training would still cause them to generate errors sometimes.
So it's baked into the process itself, not just bad data.
That seems to be the argument. It's a consequence of learning language patterns versus learning factual truth.
Okay, this is where it got really fascinating for me. They link it to this thing called the is it valid problem, or IIV.
Yeah, the binary classification idea.
Right, and the core idea is that it's actually harder for an AI to generate a correct answer from scratch than it is to just look at an answer and say, yep, that's valid, or nope, that's not.
So creating is harder than checking.
Basically, yeah. The math apparently shows that the rate of generating errors is directly tied to how often the model messes up on that simpler, is this valid question.
The very act of generating text seems predisposed to a certain level of error.
And these aren't random errors either. They're predictable, statistically speaking.
Yeah.
One big factor they identified is arbitrary facts.
Things without a clear pattern, like names or dates.
Exactly. Information that doesn't fit into a broader linguistic or logical structure, the model can learn easily.
Like the birthday example again. If a specific birthday only shows up once in that huge data set, they call that a singleton, right?
A singleton fact.
And the paper shows that the rate of those singletons directly predicts how often the base model will hallucinate on them if, say, 20% of birthday facts only appear once. You can expect at least a 20% hallucination rate for birthdays.
Wow. So for you listening, if you're trying to get an AI to pull up a unique product ID or a very specific rare version number from some internal documentation.
That singleton issue is a big potential problem. Unless that fact is repeated many times, the model might just guess.
Okay, what else? They mentioned poor models, too.
Yeah, this is about the model's architecture basically being unsuitable for the task, like trying to draw a circle using only straight lines.
The model just isn't built right for certain things.
Kind of. Remember the DeepSeek example, counting the Ds? DeepSeek v3 struggled because of how it breaks words into smaller pieces or tokens.
So its internal representation made counting hard.
Right. But a different model, DeepSeek R1, which is built more for reasoning, handled it fine. So the type of model matters.
Makes sense. And then there were a few others. Computational hardness.
Yeah, for problems that are just fundamentally complex, even for an AI, think really tricky diagnostics.
Distribution shift.
That's when you ask it about stuff way outside its training data, like feeding it specialized network logs it's never seen before. It might just output nonsense.
And the classic garbage in, garbage out, GI go.
Of course. If the training data has errors, the model learns those errors. Always a challenge.
Okay, that covers the pre-training part. But models also go through post-training, right? To fine-tune them.
They do, often specifically to reduce hallucinations and make them safer or more helpful.
But the paper argues this doesn't always fix it. It might even make it worse.
That's the really provocative part. They argue that current post-training methods, combined with how we evaluate these models, actually perpetuate the problem. It's a socio-technical issue.
How so? What's the problem with evaluation?
It comes back to that student exam analogy. Most AI benchmarks use a simple binary score. 1 point for correct, 0 for incorrect.
And crucially.
Crucially, 0 points for saying, I don't know, or just not answering.
So there's no penalty for guessing wrong compared to just admitting ignorance?
Exactly. This creates what they call an epidemic of penalizing uncertainty. If you're the AI, the best strategy to maximize your score under these rules is always to guess when unsure.
You never gain points by saying, I don't know, but you might get lucky guessing.
Precisely. So the models are constantly incentivized to be in test-taking mode to bluff rather than admit they don't know. It's a systemic incentive problem we've created.
And they showed this applies to major benchmarks, right? The ones used to rank models.
Yeah, Table 2 in the paper is pretty damning. GPQA, MMLU Pro, SWE Bench, HLE. Loads of important ones use this binary scoring with no credit for I don't know.
Even ones evaluating real user chats might score a response with factual errors higher than a simple I don't know.
Right. So even if we add specific tests for hallucinations, if the main benchmarks still reward guessing,
the models will keep learning to guess. We're training them to do it.
It seems that way. The core incentives are skewed.
Let's take a brief break for a special message from our producer, Kurt Robbins.
Hi, this is Kurt Robbins. First, thanks for listening. I truly appreciate your support. I want to let you know that I'm currently accepting new clients. My rates are affordable, and I have more than 25 years of experience working for enterprise companies like Microsoft, Northrop Grumman, Oracle, PNC Bank, FedEx, USAA, and Wells Fargo, among many others. If you want to improve your IT documentation and communications, hire me. I deliver fast, know how to use AI to improve efficiency and accuracy, and love going the extra mile to satisfy my clients. Thank you for subscribing and listening. Back to you, Daphne and Fred.
Welcome back to the AI for Technical Writers podcast. We were just talking about how current evaluation methods might actually be encouraging AI hallucinations.
Right, because they penalize saying, I don't know, just as much as giving a wrong answer.
So the big question is, how do we fix this? If the evaluation system is the problem, what's the solution?
The paper proposes a really interesting shift in philosophy. It's about changing the rules of the exam.
Wow.
By explicitly stating confidence targets in the instructions for each question or task.
Okay, what does that look like in practice?
Imagine a prompt that says something like, answer only if you are more than 2 confident. Mistakes will be penalized 2 divided by 1 minus 2 points. Correct answers get 1 point. Answering I don't know gets 0 points.
Whoa. Okay, so you explicitly define the penalty for being wrong based on a confidence threshold too.
Exactly. It makes the trade-off crystal clear. For example, if you set t to 0.5, the penalty for a mistake is 1 point, same as the reward for being right.
So the model should only answer if it thinks its chance of being right is better than 50-50.
Precisely. If you set t higher, say 0.8, the penalty for mistakes becomes much larger, incentivizing the model to be much more cautious.
The key is that it's explicitly stated in the instructions. It's not hidden.
Right. This allows for objective grading based on that threshold and encourages what they call behavioral calibration.
Teaching the model to accurately assess its own confidence level.
Yes, and to only respond when it meets that required level of certainty for a given task, like training an expert who knows when to be definitive and when to say, well, I'm reasonably sure, but...
And the really practical suggestion here, especially for our audience, is to incorporate these explicit confidence targets into existing mainstream benchmarks, like the SW bench for programming, for example.
So not necessarily inventing whole new tests, but changing the scoring rules of the ones that already drive development.
Exactly. Realign the incentives. Reward appropriate uncertainty instead of punishing it. And for technical writers, IT pros, the outcome could be AI tools that are not just more accurate, but more honest about their limits.
Imagine an AI saying, okay, based on the documentation, I'm 80% confident this is the solution, or I lack sufficient data to confirm that specification.
That feels much more trustworthy, doesn't it? Knowing the AI's confidence level.
Absolutely. It's about fostering AI that communicates its knowledge state more transparently.
You know, this whole discussion makes you wonder, if we succeed in training models to be behaviorally calibrated like this, what's the next step?
What do you mean?
Well, beyond just saying, I don't know, could they learn more nuanced ways to express uncertainty, like humans do?
Yeah, like hedging, saying it might be, or one possibility is.
Yeah, or maybe omitting details they aren't sure about, or even asking clarifying questions when they hit their confidence limit.
That's a fascinating thought. Moving from just generating text to actually participating in a more cautious, collaborative information exchange.
Mimicking the sophisticated ways humans handle uncertainty in conversation. That feels like a crucial step towards building AI we can truly rely on as partners, not just answer machines.
A truly calibrated AI wouldn't just avoid blatant errors, it would know how to communicate its limitations effectively. That's a powerful idea.
Thank you for listening to the AI for Technical Writers podcast, where we help you get smarter than your competition.
Remember to like, subscribe, comment, and share.
We'll see you next week.